Hi, I'm Cindy Mascone, editor of Chemical Engineering Progress magazine. I'm here today with Bill Koros, a professor of
Just go ahead and start again. It's fine. We'll just, you don't have to turn it off, actually.
Hi, I'm Cindy Mascone, editor of Chemical Engineering Progress magazine. I'm here today with Bill Koros, a professor in the School of Chemical and Biomolecular Engineering at Georgia Institute of Technology. Bill was named the 63rd AIChE Institute Lecturer, and he just finished giving his talk entitled Beyond Water, Expanding the Spectrum of Efficient Large-Scale Separations. It was a very interesting presentation, and for those of you who weren't able to attend, I encourage you to watch the video of it, which will be available soon on AIChE's website by clicking on Chem-E on Demand. Bill, thanks for taking the time to talk to us. One of the things that caught my attention during your talk was you called membranes and solvents the dynamic duo of separations. Can you tell our viewers a little bit more about that?
Sure, Cynthia. Basically, membranes and sorbents, they cover different areas of the spectrum of separations. For instance, if you have a very concentrated solution and you want to make it much more concentrated, a membrane is exactly what you need. A good example would be if you had 79% nitrogen, in other words air, and you wanted to make 95% nitrogen. Membrane is perfect because you just shove across enough oxygen to increase the concentration to 95 or 99%. On the other hand, if you're trying to pull out a small amount of CO2 out of a flue gas and capture the CO2, the membranes may not be so convenient for that, and so as a result, sorbents are very good. In some cases, membranes may work, but sorbents actually can reach out and essentially grab the CO2, collect it, and then at the end of the sorption cycle, you simply heat it up and off comes almost pure CO2. So those two can cover a range of concentrations that each of them individually would have a difficult time doing. So sorbents are really great, membranes are really great, but both of them are great because they use much less energy than the conventional way of doing separations, which generally involves a phase change, and membranes and sorbents really avoid that problem.
Good, thank you. And you also talked about how realizing the potential of membranes is a unique, chemical engineers are uniquely suited to that, and you mentioned modeling, the need to model these things. Could you talk a little bit about that also?
Yeah, I would say when I started in this field, I thought everything was materials, and materials is very, very important in solving the problem. But knowing what material to make largely requires having somebody that has done a process model that says if you could simply insert a membrane or a sorbent at this spot, you could then hugely save energy. So modeling is critical, and then the materials component comes in to try to basically make a material that'll do what the model said I needed to do. And ultimately, all of this really has to get integrated in a separations kind of a perspective to try to make it. You can't just make a device, it has to be integrated into the overall process. So that's where chemical engineering, there is no other discipline that can do all of those things well. And so that's why I think this is such a unique opportunity for our institute.
Well, I think you're right on that. I think it's something that chemical engineers are really suited for. Thanks again, Bill, for taking the time to speak with us.
Great, Sid. Thanks.